Hey everybody, I'm Mark Harrio. I'm a remote student at Full Stack Academy, and we were given an open-ended discussion opportunity to discuss any particular technology topic of interest. So as a junior developer, I decided to take the opportunity to study Git, which I believe to be one of our most commonly used tools. It's something that I will most likely leverage on a daily basis. And there's a few things about it that are pretty confusing, so I figured it would be an appropriate topic for this session. I can go ahead and share my screen. So I'll talk a little bit about the philosophy and some workflow, and then a few details on use and some helpful commands. Go and go full screen here. So leading up to Git, as software engineers, it's necessary to track changes to code bases and to computer files. So for many years, they used what's called a CVS, or a central version system, which is not ideal for many reasons. Here's a quote from Linus Torvalds: "If you're not distributed, you're not even worth using. It's that simple." And it is more than just about offline work. The whole difference here is that a distributed version system like Git allows every user of the database, every user of the project, to keep their own unique copy, which they can freely experiment with without breaking anything on the central copy, which is really, really critical to modern software engineering and software development. So two of the other issues with the central version system are this commit access wall situation, where it's almost like a golden key. Like, you have to choose which of your employees have the know-how to actually commit to the central copy, and it's not ideal. So, and another advantage of Git is that it is open source. So, of course, Git is not the only distributed version control system out there. There are many advantages to Git specifically. It's reliable, it's atomic. Several of the older systems that it replaced would struggle with data corruption. And these commits they're compact, and they store only the changes. So the commit is like the basic unit of a Git action. What it does is it records all of the changes to all of the files in the project directory, which it is more sensible than tracking individual files like many of the other systems used to do. And what's cool is that it leverages a very simple data structure. It's just a simple linked list. It's one of like the first exercises in basic programming. And to me, I think it's really cool, and it's something we're thinking about, that such a simple tool is so powerful in so many different, it makes it more a general tool to solve general problems by being simpler, and less is more kind of thing. And of course, Git also pairs with GitHub, which promotes sociability. People can look at each other's pull requests, and you can look line by line at every change that's being made. And the fact that it's open source is excellent, both for promoting hobbyists to sort of dabble freely, and so it encourages that curiosity and exploration. So a little bit more about open source software. This really is one of the things that I am passionate about, because I feel that the internet offers us, as a culture, the ability to communicate openly. And so I think open source is really just absolutely what it's all about. And so, of course, Linus has a comment here as well that security and code quality are improved because everybody's looking at it. As soon as there's a problem, anybody can fix it. Anybody can submit a pull request. And its openness is a very strong aspect to it. So this is also useful for businesses, as they can try out new code bases without having to be locked into anything, and they can make changes as they see fit. And of course, it's openly available to private hobbyists. There's no excessive expense up front. And so philosophically, as I was saying, it opens the door for anybody in the world to look at these projects. As a curious person, I can download, I believe the Unreal Engine just went open source recently, and you can go through and just learn and just study and just explore it. And there's so much there. So I think that's really a wonderful advantage to open source software and Git. So a couple different usage models. This is something where we get a little tripped up. And some of this text may be a little hard to read, but hopefully the arrows are pretty clear. This is one example of a Git workflow that I found on a blog. You see the source there at the bottom, where essentially there is a central a central branch. Now, technically, that branch is not different in any way from any other branch, except that all of the people working on this project recognize it as the master branch. But what that allows for is for all of these 4 developers to push and pull amongst themselves, to share changes between each other, and to work collaboratively without affecting the original project, which is really critical and very, very useful, especially as software development continues to spread across remotely across the internet. So here it's another image with some small text. I'll just try to sort of explain a little bit. You see on the left, the arrow pointing down is time moving forward. On the far right, the vertical line is the master branch. And then the line immediately to the left is the hotfixes branch. So this is sort of a development philosophy that can be used with Git, where this develop branch, you see all the yellow dots down the center. So if you're working on a new product or a new feature for your product, you can branch off to the develop branch and work completely isolated from the master branch. And then there's fewer commits to the master. And so the benefit here is that somebody can be working on a new feature and we can suddenly respond to a need for a hotfix by simply creating another branch. And that's a really, really strong advantage to the distributed Git model, as opposed to the central store, which is very difficult to branch and far less agile. So a few distinctions that were a little confusing early on, I'd like to mention quickly. Forking versus branching. So when you fork a repo, what it's actually doing is creating a complete copy of that repo. And typically what that will be for is when a new organization is starting a new project, you will begin with a fork. And what this is that it's now a new repo that you own. So those that want to change your code will submit pull requests to you, and you will approve them to pull these changes into your code base, as opposed to a branch, which is a very small object. And you're intended to be using branches. 5, 10 branches active is not crazy. And this is how you actually work within the Git environment. So that was a little confusing at first. Hopefully that helps clear it up. That basically forking is done at the start of a new project, and then branching is done frequently throughout the work process. So one other confusion, reset versus revert. So these $signs here is intended to be terminal input. The git reset will just simply undo the previous commit in the local repository. But the problem with that is that you cannot apply this change upstream to, how should I phrase it? You cannot commit that because there isn't actually a commit being created. Whereas git revert will actually create a new commit that cancels out the previous. So the difference here is that one is local and one can be pushed to a remote repository. So for example, the reset is used if you screw something up, and it's basically your undo button, essentially. Whereas revert says, we as a group broke something, we as a group move back to a prior commit. And so one sort of random tip here, this head ~2, that is saying to go from the head pointer and go back 2 commits. So essentially this command will set you back 2 commits. And so head, there's also a number of customizable tags. Head is one of the defaults. I don't have a slide for creating those, but that is another trick to look into. So merging versus rebasing. There's some pros and cons to each. I want to talk about them for just a minute or two. So our starting situation, I tried to blow these pictures up. I realize now the text is very blurry, but the blue branch along the bottom is the master branch, and the green branch is a feature branch. So essentially the idea here is that I, as one person, created a branch, started working on a project while my teammate made improvements to the master branch. And I want to incorporate those improvements to the master branch into my own working directory. So merging and rebasing are 2 different ways to do that. So how do they differ? Merging is non-destructive and essentially creates a new commit that summarizes all of the commits that have occurred since you branched. So there's the advantages and disadvantages here is that it creates a commit every time you do this. So every time you want to pull in commits from your master branch, which may or may not be particularly meaningful, you will be creating another commit for that change. And that can just clutter up your project history. So rebasing is different in that it actually places your branch beyond the master commit. If it's used incorrectly, this can cause catastrophic losses. So the advantage is that it'll keep a clean project history if used correctly. So the golden rule is anybody else looking at this branch? If so, do not rebase. And then you can hopefully, because here you see a situation where that has occurred and several commits were just lost and there's no getting them back. So the advantage to rebasing is that it can clean up your project history. One more thing you can do is this -I option, which is called the interactive rebasing. And that allows you to pick and choose the number of commits you will see in your log afterwards. So here's a few quick advanced commands. I'll just take a minute or so glossing over these quickly. This git log -1 line can be very helpful if, sorry. So you see, this just prints out your commits on one line each instead of that, which is much more difficult to read. In fact, I have to scroll just to get through it all. So that's a very nice thing. And then the git log -p will actually show changes between files. So these are both really nice features that I wanted to at least briefly mention, and something you can look into more. Stash and stash pop are how you put work in progress files away, pull them back out, should you need to check out between branches. Because that's really the advantage too of Git, is that you can rapidly and easily switch between working states. So that's about the gist of my Git discussion. I have some links here. The one last thing I do want to say is Git help is a very useful resource. I can simply type Git help log, and don't forget that this is here, because there's a lot of good stuff here, pages, and there's a couple diagrams and things found in there. So I would encourage you to check that out, and there's a couple other links, and thanks for your time.